Rewiring three-way switches with knob and tube wiring requires careful attention to detail. Here are the steps to guide you through the process. The first step involves identifying the power wires. In the first switch box, locate the two wires that are connected to the power supply. These are typically black and white. The second step involves identifying the switch loop wires. In both switch boxes, there will be two wires that are connected to the traveler terminals of the three-way switches. These are typically red and yellow. The third step involves connecting the power to the light box. In the light box, connect the black power wire from the first switch box to one side of the light fixture. Then connect the white power wire from the first switch box to the neutral terminal on the light fixture. The fourth step involves connecting the switch loop wires. In the light box, connect one end of the red traveler wire from the first switch box to one side of the traveler terminal on the light fixture. Connect the other end of the red traveler wire to one side of the traveler terminal on the second switch box. Repeat the process with the yellow traveler wire, connecting it to the other side of the traveler terminals on the light fixture on the second switch box. The fifth step involves connecting the other wire in the light box. In the light box, there will be another wire that is connected to a separate circuit. This wire can be any color except green or bare copper. Connect this wire to the remaining terminal on the light fixture. The sixth step involves connecting the grounds. If there are any bare copper or green ground wires, connect them together with a wire nut. The seventh and final step involves testing the circuit. Turn on the power and test the switches to ensure that the light fixture works correctly with both switches. It is important to remember that due to the age of the knob and tube wiring, it is recommended to have a qualified electrician inspect and certify the work before using it. Always follow all safety precautions when working with electrical circuits. Understanding electrical concepts such as voltage, current, and resistance is important when working with electrical wiring. Voltage, measured in volts, is the electrical potential difference between 2 points in a circuit. Current, measured in amps, is the flow of electrical charge through a circuit. Resistance, measured in ohms, is the opposition to the flow of current. Ohm's law, a fundamental principle in electrical circuits, states that voltage equals current times resistance, volts equals amps times ohms. This relationship can be used to calculate voltage, current, or resistance in a circuit if the other two values are known. When working with electrical wiring, it's also important to understand the National Electrical Code, or NEC, which provides guidelines and standards for safe electrical installations. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is essential to consult the NEC to ensure that all electrical work is performed in accordance with the code. When working with knob and tube wiring, it's particularly important to be aware of its limitations and potential hazards. Knob and tube wiring is an older type of wiring that was commonly used in homes built before the 1940s. It consists of single insulated conductors supported by ceramic knobs and run through ceramic tubes where they pass through framing members. Knob and tube wiring is not grounded, which means that it does not provide a path for fault current to return to the source in the event of a short circuit. This can make it more dangerous than modern wiring systems. Another potential hazard of knob and tube wiring is that the insulation can become brittle and cracked over time, which can increase the risk of electrical shock or fire. For these reasons, it is generally recommended to replace knob and tube wiring with modern wiring systems whenever possible. When working with electrical wiring, always use the proper tools and equipment. This includes insulated screwdrivers, wire strippers, pliers, and a voltage tester. Never work on electrical circuits while they are energized. Always turn off the power at the circuit breaker or fuse box before working on any electrical wiring. Double check the circuit is de-energized using a non-contact voltage tester, for example, before touching any wires. Wear safety glasses to protect your eyes from flying debris. If you are not comfortable working with electrical wiring, it is best to hire a qualified electrician to do the work for you. Electricity can be dangerous, and it is important to take all necessary precautions to avoid electrical shock or fire. Before beginning any electrical work, take some time to plan the project and gather all of the necessary materials. Make sure that you have a clear understanding of the wiring diagram and the steps involved in the project. If you are unsure about anything, consult with a qualified electrician. When making electrical connections, always use the proper connectors and wire nuts. Make sure that the connections are tight and secure to prevent loose wires, which can cause arcing and overheating. When running new wiring, follow the NEC guidelines for wire size, conduit fill, and support. Use the appropriate type of wire for the application, such as non-metallic sheath cable for general wiring or armored cable for use in damp or wet locations. When installing electrical boxes, make sure that they are properly grounded and securely mounted. Use the correct type of box for the application, such as metal boxes for use with metal conduit or non-metallic boxes for use with non-metallic sheath cable. When installing electrical devices, such as switches and receptacles, make sure that they are properly grounded and securely mounted. Use the correct type of device for the application, such as a three-way switch for controlling a light from two locations or a ground fault circuit interrupter, or GFCI, receptacle for use in damp or wet locations. When working with electrical panels, be extremely careful. Electrical panels contain high voltage, and it is possible to receive a severe electrical shock if you come into contact with energized parts. Never work on an electrical panel while it is energized. Always turn off the power to the panel at the main breaker before working on any of the circuits. When working with electrical circuits, it's also important to understand the concept of circuit loading. Circuit loading refers to the amount of current that the circuit is carrying. It's important to make sure that the circuit is not overloaded, as this can cause the circuit breaker to trip or the wires to overheat. To determine the circuit loading, you can use a clamp-on ammeter to measure the current flowing through the circuit. The ammeter will display the current in amps. The maximum allowable current for a circuit is determined by the size of the circuit breaker or fuse. For example, a 15 amp circuit breaker is designed to protect a circuit that is carrying no more than 15 amps of current. If the current exceeds 15 amps, the circuit breaker will trip, interrupting the flow of electricity. It's important to avoid overloading circuits, as this can create a fire hazard. If you find that a circuit is frequently tripping, it may be necessary to reduce the load on the circuit or to install a larger circuit breaker. However, it's important to note that you should never replace the circuit breaker with a larger one without first consulting with a qualified electrician. Replacing a circuit breaker with a larger one can create a dangerous situation, as the wires may not be able to handle the increased current. The NEC provides guidelines for determining the proper wire size for a given circuit load. The wire size must be large enough to carry the maximum current that the circuit is expected to carry. In addition to circuit loading, it's also important to be aware of voltage drop. Voltage drop refers to the decrease in voltage that occurs as electricity flows through a wire. Voltage drop is caused by the resistance of the wire. The longer the wire, the greater the voltage drop. Excessive voltage drop can cause problems with electrical equipment, such as dimming lights or malfunctioning appliances. To minimize voltage drop, it's important to use the proper wire size for the application. The NEC provides guidelines for determining the proper wire size to minimize voltage drop. When working with electrical wiring, it's also important to be aware of the different types of wiring methods that are available. The most common types of wiring methods include non-metallic sheath cable, armored cable, and conduit. Non-metallic sheath cable, also known as Romex, is the most common type of wiring used in residential construction. It consists of two or more insulated conductors enclosed in a non-metallic sheath. Non-metallic sheath cable is relatively easy to install and is suitable for use in dry locations. Armored cable, also known as BX, consists of insulated conductors enclosed in a flexible metal sheath. Armored cable is more expensive than non-metallic sheathed cable, but it provides better protection against physical damage. Armored cable is suitable for use in both dry and damp locations. Conduit is a rigid metal or plastic tube that is used to protect electrical wiring. Conduit is typically used in commercial and industrial applications, but it can also be used in residential construction. Conduit provides the best protection against physical damage and is suitable for use in all locations. When choosing a wiring method, it's important to consider the application and the environment. For example, if you are wiring a garage, you may want to use armored cable or conduit to protect the wiring from physical damage. If you are wiring a bathroom, you will need to use a GFCI receptacle to protect against electrical shock. Always follow the NEC guidelines for the selection and installation of wiring methods. Grounding is an important safety feature in electrical systems. Grounding provides a path for fault current to return to the source in the event of a short circuit. This helps to protect people from electrical shock and to prevent fires. All electrical equipment should be properly grounded in accordance with the NEC. Grounding can be achieved by connecting the metal enclosures of electrical equipment to a grounding electrode, such as a ground rod or a metal water pipe. The grounding electrode should be buried in the earth and should be connected to the electrical panel with a grounding conductor. In addition to grounding, it's also important to use overcurrent protection devices, such as circuit breakers and fuses. Overcurrent protection devices are designed to protect electrical circuits from overloads and short circuits. When an overcurrent occurs, the overcurrent protection device will trip, interrupting the flow of electricity. This helps to prevent damage to electrical equipment and to prevent fires. Circuit breakers are reusable overcurrent protection devices that can be reset after they trip. Fuses are non-reusable overcurrent protection devices that must be replaced after they blow. When selecting an overcurrent protection device, it's important to choose one that is properly sized for the circuit. The overcurrent protection device should be sized to protect the wiring and the equipment that is connected to the circuit. The NEC provides guidelines for determining the proper size of overcurrent protection devices. Electrical work can be dangerous, and it's important to take all necessary precautions to avoid electrical shock or fire. If you are not comfortable working with electrical wiring, it's best to hire a qualified electrician to do the work for you.